Have you ever watched a star streak across the night sky and made a wish? That fleeting flash, a sudden blaze of light darting through the darkness. It feels like magic, a secret moment just for you. But what are these glowing visitors really? Tonight, we'll slowly unravel the mysteries of falling stars, those brilliant meteors that paint our skies and whisper stories from the far reaches of space. As you settle in, ready to drift into sleep, imagine yourself beneath a vast velvet canopy sprinkled with countless pinpricks of light. Somewhere far above, tiny travelers from distant worlds are hurtling toward us, silently crossing the cosmic ocean. They begin their journey in silence, gliding through the void, invisible to all but the most sensitive instruments. Then, as they near our planet, they meet a fiery welcome, a glowing blaze that ignites the night, capturing our imagination and curiosity. But where do these visitors come from? What secrets do they carry? And how do they turn into the falling stars we see? We will gently explore the science behind meteors, from their birth in ancient asteroid belts and comet tails, to their fiery passage through Earth's atmosphere, and sometimes to the rare moments when they reach the ground as meteorites, pieces of other worlds resting quietly on our soil. As you listen, allow the quiet rhythm of the cosmos to soothe you. No hurry, no rush, just the slow, beautiful dance of space debris, light, and gravity, told softly for you to drift off into wonder and rest. Far beyond our atmosphere, in the silent depths of space, lies a sprawling collection of rocky leftovers, the asteroid belt. This vast region, orbiting the Sun between Mars and Jupiter, is filled with countless fragments of rock and metal, remnants from the early days of our solar system, when planets were still forming and the chaos of creation ruled. These fragments, ranging from tiny dust specks to massive boulders hundreds of kilometers across, drift slowly in their ancient paths. But sometimes, gravitational nudges from planets or collisions between asteroids send some of these space rocks careening toward the inner solar system, setting them on a collision course with our Earth. Imagine a tiny speck of rock, perhaps no bigger than a pebble, silently wandering through this cosmic junkyard. For millions of years, it has floated in the cold vacuum, untouched and unremarkable. But as it crosses paths with Earth's orbit, it is suddenly caught in a gravitational embrace, pulled inexorably toward the planet. This moment marks the beginning of a breathtaking transformation, from silent traveler to fiery spectacle. As our atmosphere grows denser closer to Earth's surface, it meets the speeding visitor. The friction between the rock's surface and the thin air molecules compresses the air in front of it, heating it to thousands of degrees. The rock itself begins to glow, first a faint shimmer, then a brilliant blaze. This glowing trail is what we call a meteor, or, more poetically, a falling star. But unlike stars, these fiery streaks are fleeting, lasting only a few seconds as they blaze across the night sky, burning up entirely or breaking apart in mid-air. What's remarkable is how thin and fragile our atmosphere is compared to the vastness of space. To us, it feels like an invisible shield, delicate yet powerful, protecting us from countless meteoric visitors every day. Most meteors are tiny, no bigger than a grain of sand, and they burn up completely before reaching the ground. These are the silent fireworks of our planet, lighting the sky with invisible, gentle shows for those who look up quietly at night. But every now and then, a larger fragment survives this fiery passage. It slows down, the glow fading, and it crashes onto the Earth's surface as a meteorite, a tangible piece of space history carrying secrets from the early solar system. Scientists prize these space rocks, studying them as time capsules that hold clues to our cosmic origins, the ingredients that led to planets, and ultimately, life itself. If you're lucky enough to witness a bright meteor, often called a fireball or a particularly spectacular meteor shower, you're glimpsing the ongoing conversation between Earth and space. These events connect us to the grand scale of the universe, a reminder that our small planet is part of a vast and dynamic system filled with wonder and mystery. As you drift deeper into sleep, think of those silent rocks, their long journey across the void, and the brief, brilliant flash that brings them to our attention. The mysteries of meteors are many, their stories ancient and ongoing, whispered in light and fire across the night sky. Beyond the simple glow of a meteor lies a hidden complexity, the many shapes, sizes, and compositions of these celestial visitors. Meteoroids, as they are known while still drifting through the vast emptiness of space, are incredibly diverse. Some of these tiny travelers are solid chunks of metal, primarily iron and nickel, forged in the molten cores of ancient asteroids long since shattered by cosmic collisions. These metallic meteoroids are like fragments of the deep interiors of these space rocks, preserved in the cold silence of the cosmos for billions of years, quietly orbiting the Sun, along with countless others. Others are rocky in nature, composed mainly of silicate minerals, the same kinds of rocks that make up Earth's crust and mantle. These rocky meteoroids range from tiny grains no bigger than a grain of sand, all the way up to massive boulders capable of causing great impact when they meet our atmosphere. And then there are the most fragile and mysterious among them, the carbonaceous chondrites. These are porous, dusty, and often crumbly, rich in organic compounds, water-bearing minerals, and complex molecules that may hold the secrets to how life itself began. These delicate meteoroids are considered time capsules, relics of the early solar system that have remained mostly unchanged since the dawn of time. Imagine, just for a moment, one such fragile, dusty rock drifting silently through the cold vacuum of space. It's older than the Earth itself, more than 4.5 billion years old, formed before our planet was even a bright spark in the swirling cloud of dust and gas that birthed our solar system. This tiny traveler carries within it the raw materials that helped seed our planet, the very ingredients that would one day spark the chemistry of life, the molecules that may have drifted across space for billions of years without ever knowing the warmth of a sun or the touch of water. Every meteor that reaches the surface of our world may hold fragments of that primordial soup, frozen in time. Molecules that have traveled across the vast distances of space, untouched and unchanged, carrying stories older than anything on Earth. But not all meteoroids survive their journey to Earth intact. Entering Earth's atmosphere is a violent and unforgiving process, a trial by fire in the literal sense. When these ancient space rocks plunge into the thickening blanket of air that surrounds our planet, they encounter rapidly increasing resistance. The air is suddenly compressed in front of the meteoroid, heating up to thousands of degrees, far hotter than the surface of the Sun. This intense heat causes the outer layers of the meteoroid to vaporize in a process called ablation, leaving behind the glowing trails and streaks of light we call meteors, or shooting stars. We see them as brief, sparkling arcs across the night sky, beautiful and mysterious, but also fleeting reminders of something far more powerful and primal. The larger the meteoroid, the more intense this atmospheric entry becomes. Massive objects can produce spectacular fireballs, brilliant explosions of light that can temporarily brighten the sky like a second sun. Sometimes these fireballs are so powerful that they create booming sonic shocks that ripple across the surface, shaking windows and rattling the ground. These are known as bolides, the fiery heralds of celestial impacts, their explosive energy sometimes equaling or exceeding that of a small nuclear bomb. One of the most remarkable recent examples of this was the Chelyabinsk meteor event on February 15, 2013. Over 20 meters wide and weighing an estimated 13,000 metric tons, this meteoroid entered Earth's atmosphere at roughly 19 kilometers per second, fast enough to circle the Earth in just over an hour. As it streaked across the sky above the Russian city of Chelyabinsk, it exploded with a force equivalent to roughly 500 kilotons of TNT, a shockwave so powerful that it shattered windows across 6 cities, damaged thousands of buildings, and injured more than 1,000 people. The sheer power of this event was a vivid reminder that Earth is still very much a part of a dynamic and sometimes violent cosmos. The Chelyabinsk meteor arrived without warning, highlighting how many such objects, especially smaller ones, can approach unseen and unannounced. In response, scientists and space agencies around the world have dedicated increasing efforts to monitor the skies for near-Earth objects, or NEOs, asteroids and comets whose orbits bring them close to our planet. Telescopes scan the darkness night after night, looking for faint moving points of light, while radar systems map the trajectories of known objects, helping to predict potential impacts years or even decades in advance. Despite these efforts, the vastness of space means countless smaller meteoroids remain undetected until their blazing descent lights up our skies, their arrival sudden and unexpected. Each meteor, regardless of size, is a cosmic messenger, a piece of the puzzle that helps us understand the history of the solar system and our place within it. Scientists study the recovered fragments of meteorites to learn about the conditions that prevailed billions of years ago, before Earth's formation, and to unravel the processes that led to the birth of planets and the emergence of life itself. Some meteorites contain amino acids, the building blocks of proteins, hinting that the seeds of life may have come from space, delivered by these celestial travelers. As you drift slowly towards sleep, allow your mind to wander with these tiny ancient voyagers. Picture the vast, cold expanses they traverse, the silent ballet of cosmic orbits, the fiery kiss as they meet Earth's atmosphere, and their fleeting moment of brilliance across the night sky. They are reminders of the universe's ceaseless motion, the endless dance of matter and energy, and the mystery that surrounds us all. When you look up at a shooting star streaking across the night sky, it might seem like a simple, almost magical moment, a brief flash of light, so fleeting it's gone before you can fully grasp it. But behind that shimmering trail lies a dramatic story of interaction between space and atmosphere, an ancient cosmic dance with forces that have shaped our world for billions of years. These meteors are not just pretty streaks. They are the result of powerful physics, relentless friction, and transformation on a scale that humbles the imagination. To understand why meteors glow so brightly and why their trails flicker and dance, we need to dive deeper into the atmospheric entry process, the invisible battleground where cold space meets the warm breath of Earth's air. Imagine a meteoroid hurtling towards Earth at a speed that can exceed tens of kilometers per second. That's many times faster than a bullet, and fast enough to cross an entire country in just a few seconds. As it plunges into the upper atmosphere, the air ahead of it doesn't have time to move out of the way. Instead, the gas molecules are violently compressed, raising the air temperature to thousands of degrees. This sudden compression generates a shock wave, an invisible wall of extreme pressure and heat that forms just in front of the meteoroid. The heat from this shockwave transfers to the meteoroid's surface, causing the outer layers to vaporize and shed as glowing plasma, the source of the spectacular light we see. But the glowing isn't just from the meteoroid itself. The air around it becomes ionized, stripped of electrons by the intense energy, forming a glowing sheath of charged particles, a plasma trail that can stretch for kilometers across the sky. This trail is often what makes meteors so visible even when the solid rock behind it is relatively small. The trail's shape and flickering nature depend on the meteoroid's size, speed, angle of entry, and the composition of both the meteoroid and the atmosphere. The plasma can persist for several seconds or minutes, slowly dispersing and leaving an ethereal glowing path that fades like a ghost's breath. One of the most curious aspects of meteors is their erratic flicker and twinkle. Unlike the steady light of planets or stars, meteors can flare suddenly, dim, brighten, or even break apart mid-flight, showering tiny fragments across the sky. This behavior stems from the intense and chaotic forces at play during atmospheric entry. The meteoroid experiences immense pressure and heat, often unevenly distributed across its surface. Fragile or porous meteoroids may fracture, sending pieces tumbling and fragmenting in a dazzling cascade. Sometimes these fragments themselves become miniature meteors, glowing and burning independently before fading away. This fragmentation process can create meteor showers, spectacular celestial fireworks that captivate stargazers and scientists alike. While most meteoroids disintegrate entirely during this fiery descent, some larger and sturdier fragments survive the ordeal and reach Earth's surface as meteorites. These surviving pieces are invaluable to science. They offer direct samples of material from asteroids, comets, or even the Moon and Mars, bearing the chemical and isotopic fingerprints of their origins. When scientists analyze these meteorites, they uncover stories of the early solar system, how planets formed, how water and organic compounds arrived on Earth, and how cosmic events shaped the evolution of our planetary neighborhood. In a sense, meteorites are messengers from the past, carrying whispers from the dawn of time to our laboratories here on Earth. The mystery deepens when we consider where these meteoroids come from. Many originate in the asteroid belt, a vast ring of rocky debris orbiting between Mars and Jupiter. These fragments are remnants of a primordial planet that never fully formed, their orbits occasionally nudged by gravitational forces into paths that intersect with Earth's orbit. Others come from comets, icy bodies from the distant reaches of the solar system that shed dust and small rocks as they approach the Sun. When Earth crosses these dusty cometary trails, we experience meteor showers, the regular annual events that light up the night with thousands of shooting stars per hour. These showers, like the Perseids or Leonids, have inspired wonder and folklore for centuries, connecting human culture to the rhythms of the cosmos. Yet despite centuries of observation, meteors still hold secrets. The exact composition and structure of many meteoroids remain unknown until fragments are recovered and studied. Some meteoroids exhibit unusual behaviors, like glowing longer than expected or producing mysterious radio signals during atmospheric passage. Others produce rare types of meteorites that challenge existing theories about the formation of the solar system. Scientists continue to develop new technologies, from all-sky cameras to radar and satellite sensors, to capture meteors in greater detail, hoping to unlock these mysteries and improve our understanding of these cosmic visitors. As you let your mind drift gently toward sleep, imagine these ancient space travelers, silent voyagers shaped by gravity and time, blazing across the dark sky, igniting for a moment in a brilliant flash. They remind us of the vastness beyond, the hidden stories waiting just out of sight, and the timeless connection between Earth and the cosmos. Their brief, fleeting light a soft whisper from the universe, inviting you to dream of stars, planets, and the endless night. As the meteoroid continues its fiery journey through the atmosphere, it experiences forces that are almost unimaginable. The friction and pressure not only heat the outer layers, but can also cause intense vibrations and stress within the rock itself. Imagine a fragile traveler forced to endure a storm of fire and wind, buffeted and strained by invisible but overwhelming forces. This internal turmoil often causes the meteoroid to shatter from within, breaking apart into smaller fragments that scatter like shards of glass in slow motion. These fragments may glow independently, creating a shimmering trail of mini fireballs that dance across the sky in a celestial ballet. This fragmentation process adds layers of complexity to the meteor's appearance. It can flicker, flare, and fragment unpredictably, drawing the eye and imagination into a moment of cosmic drama. But what determines whether a meteoroid will survive its plunge and become a meteorite, or whether it will burn up completely, never to be seen again except as a streak of light? Size and composition play a crucial role. Larger meteoroids have a better chance of surviving, as their thick outer layers can shield the core from complete vaporization. Similarly, the mineral makeup influences durability. Some meteoroids are made primarily of iron and nickel, which are far more resistant to intense heat and pressure, while others consist of more fragile rocky or carbonaceous material that crumbles more easily. The angle at which the meteoroid enters the atmosphere also matters. A shallow entry angle means a longer, more gradual passage through the air, potentially allowing it to lose speed and heat gradually. A steep dive, however, leads to more intense heating and pressure, increasing the likelihood of complete disintegration. Scientists often refer to the dark flight phase, the part of a meteor's descent where it slows down enough to stop glowing visibly, but continues falling through the atmosphere at a slower speed. During this phase, the meteorite cools rapidly and stops ablaze, silently descending through the night sky until it finally reaches the Earth's surface. This phase is subtle and invisible to observers, but it's critical for meteorite recovery efforts. Tracking the trajectory of a bright meteor, known as a fireball, and understanding its dark flight path allows researchers to predict where fragments may have landed, a challenging task given the complexities of wind, altitude, and the meteor's shape. Recovering meteorites is a thrilling blend of detective work, patience, and luck. Across deserts, frozen tundras, and remote wildernesses, scientists and enthusiasts comb the landscape searching for these extraterrestrial visitors. In places like Antarctica, where the landscape is mostly ice and snow, meteorites stand out starkly as dark rocks, undisturbed for millennia. Some meteorites have been found that predate Earth itself, offering an almost sacred glimpse into the primordial material from which our planet and solar system formed. Each recovered piece is a puzzle, a relic that whispers secrets about cosmic chemistry, collisions, and the conditions in distant corners of space. What's particularly fascinating about meteors is how they connect Earth to the broader universe. These bits of rock and metal that fall from the sky are tangible evidence of the dynamic and ever-changing nature of our cosmic neighborhood. The solar system is not a static place. It's a busy, bustling environment filled with debris, collisions, and the constant tug of gravitational forces. Meteors remind us that Earth is part of this cosmic ecosystem, constantly bombarded by remnants of the solar system's formation and ongoing evolution. These tiny visitors carry stories of asteroid collisions, comet outgassing, and even the violent early days of our planetary system. Throughout history, meteors have inspired awe and wonder, often interpreted as omens or messages from the heavens. Ancient civilizations across the globe recorded meteor sightings, weaving them into myths and legends. Some cultures saw meteors as the fiery arrows of gods, while others viewed them as souls traveling between worlds. In a quiet way, these human stories reflect a deep and enduring curiosity, a desire to understand the unknown, to find meaning in the flicker of light that breaks the stillness of the night. Today, as science peels back the layers of mystery, we continue to be captivated by meteors not just as objects of study, but as symbols of connection. They bridge the gap between our earthly experience and the vastness of space. When you see a shooting star, you're witnessing the fleeting intersection of two worlds, the cold silence of space and the warm embrace of Earth's atmosphere. You're seeing matter transformed by heat and pressure, light and motion converging in a brilliant arc that lasts only seconds. And yet, in that brief moment, the meteor invites you to look up, to wonder, and perhaps to dream. So next time you find yourself under a clear night sky, take a moment to watch and wait. Maybe you'll catch a meteor blazing a path above, a visitor from the cosmos slipping silently through the darkness. It's a quiet, profound reminder of the ongoing story written across the stars, a story we are all a part of, whether we realize it or not. Let that thought soothe your mind as you drift towards sleep, carried gently by the knowledge that the universe is alive with motion and light, always waiting just beyond the edge of sight. One of the most intriguing aspects of meteors is their silent passage through the night sky. Despite the intense energy involved, most meteors do not produce any sound audible to human ears on the ground. This phenomenon has puzzled many for centuries. How can a blazing fireball streak across the heavens, lighting up the darkness, yet leave us in peaceful quiet below? The answer lies in the complex relationship between the meteor's speed, altitude, and the nature of sound itself. When a meteor enters Earth's atmosphere, it is traveling at tremendous velocities, often tens of kilometers per second. This incredible speed generates shock waves in the air, compressing and heating it so rapidly that the air molecules vibrate violently, producing the visible glowing trail and sometimes a sonic boom. But the source of this noise is far above the ground, typically at altitudes between 80 and 120 kilometers. The sound waves have to travel through layers of varying atmospheric density, temperature, and wind, which scatter and dissipate the sound energy. By the time these waves reach the surface, they are often too weak or too delayed to be heard as a conventional boom at the same time as the meteor's visible streak. Sometimes, people do report hearing sounds associated with bright fireballs, described as distant booms, crackling, or hissing noises. These sounds often occur seconds or even minutes after the meteor is seen due to the slower speed of sound compared to light. This delayed acoustic arrival can create eerie and mysterious sensations. Watching a brilliant light flash overhead, then hearing a muffled boom minutes later, as if the sky itself is whispering secrets in slow motion. Scientists call these sounds sonic booms or meteor sounds, and studying them helps us better understand the atmospheric conditions and the meteor's path. Another captivating mystery is the phenomenon of electrophonic sounds. Occasionally, observers report hearing simultaneous sounds as they see a meteor, seemingly defying the normal delay caused by sound travel time. This strange effect is believed to arise from electromagnetic disturbances generated by the meteor as it ionizes the air during its high-speed descent. These electromagnetic waves can interact with conductive objects near the observer, such as metal fences, glasses, or even hearing aids, causing vibrations or buzzing noises that are heard instantaneously. Although the exact mechanisms are still being researched, electrophonic sounds add an extra layer of wonder to meteor observations, blurring the line between the physical and the mysterious. The interplay between light and sound in meteors also reflects a deeper truth about how we perceive the universe. Our senses are limited by physical laws. Light travels faster than sound, so we always see a meteor before hearing it, if we hear it at all. This delay between sight and sound can distort our experience of these events, sometimes making them seem magical or surreal. It's a reminder that what we see and hear is filtered by nature's own rules, and that the cosmos is far more complex than our immediate perception. Scientists have long sought to record and analyze meteor sounds using specialized equipment. Infrasound sensors, for instance, detect low-frequency sound waves produced by large meteors and fireballs as they disintegrate high in the atmosphere. These inaudible vibrations carry valuable information about the energy released during the meteor's passage, helping researchers estimate its size, speed, and trajectory. Such data are crucial not only for understanding meteors, but also for assessing potential threats from larger near-Earth objects that might impact the planet. Moreover, radar systems track meteors by bouncing radio waves off the ionized trails they leave behind. These trails, made of charged particles, reflect radio signals for seconds or minutes after the meteor burns up, creating glowing plasma columns that act like ephemeral radio mirrors in the sky. By monitoring these reflections, scientists map meteor showers, measure atmospheric winds, and even study the upper atmosphere's chemistry and dynamics. It's a striking example of how meteors serve as natural probes, revealing secrets of Earth's thin, fragile veil of air that protects life below. Meteor showers, a spectacular and well-loved phenomenon, bring additional layers of mystery and beauty to the night sky. Unlike random sporadic meteors, showers occur when Earth passes through streams of debris left by comets or asteroids. Each piece in these streams is usually small, often no larger than a grain of sand, but traveling at extraordinary speeds. When Earth's orbit intersects these dusty trails, countless tiny meteoroids enter the atmosphere, producing a dazzling rain of light. These predictable events are named after the constellation from which the meteors appear to radiate, like the Perseids or the Leonids, and have been celebrated for millennia. What's remarkable about meteor showers is how they connect us directly to the history of our solar system. The debris trails are remnants of comets that have orbited the Sun for thousands of years, shedding dust and ice as they melt under solar radiation. Each meteor shower is a seasonal reminder of these ancient travelers, frozen relics passing by on their eternal path. Observing a meteor shower is like peering back in time, witnessing the slow dance of cosmic dust that has drifted through space for ages, only briefly igniting as it encounters our atmosphere. At the same time, the sporadic meteors, those random shooting stars unconnected to showers, hint at the dynamic and chaotic nature of the solar system. These solitary meteoroids may be fragments from collisions between asteroids, debris left behind by long-gone comets, or particles captured by Earth's gravity from the vast interplanetary medium. Their unpredictable arrival reminds us that space is not a quiet, empty void, but a constantly shifting arena of motion, collision, and change. The wonder of meteors also extends to the rare but significant impacts when larger meteoroids or asteroids survive atmospheric entry and strike the Earth's surface. These impacts have shaped our planet's history profoundly. Giant craters, some visible from space, mark collisions that released energy millions of times greater than the most powerful human-made explosions. The impact that contributed to the extinction of the dinosaurs is perhaps the most famous example, illustrating how celestial visitors can alter life's course on Earth. Today, scientists track near-Earth objects, NEOs, meticulously, watching for any potentially hazardous asteroids that might cross our planet's path. Space agencies and observatories worldwide scan the skies continuously, cataloging thousands of these objects and calculating their orbits. This global effort is humanity's way of preparing for future impacts, aiming to protect Earth from cosmic dangers. It's a sobering, but also inspiring reminder of how meteors and their larger relatives, asteroids, remain a real and present part of our cosmic environment. Beyond danger and destruction, meteors also contribute positively to Earth's story. Some theories propose that meteorites delivered essential organic compounds or water to the early Earth, seeding the conditions necessary for life to emerge. This idea, known as panspermia, or the delivery of extraterrestrial building blocks, suggests that meteors are not just visitors, but potentially vital actors in the grand narrative of life. Each meteorite that falls carries chemical clues that help scientists piece together the puzzle of life's origins, connecting the heavens and Earth in a profound cosmic cycle. As we unravel the mysteries of meteors, we find ourselves caught between the realms of science and poetry, fact and wonder. These fleeting visitors from space spark our imagination and invite us to contemplate our place in the universe. Their brief blaze across the sky reminds us that even in the vastness of space, tiny moments of light can touch our lives, inspire dreams, and connect us to the ancient rhythms of the cosmos. So as you lie beneath the stars tonight, perhaps ready to drift into sleep, remember that somewhere above, silent and unseen, countless pieces of rock are journeying toward us, carrying the echoes of cosmic history, the fire of distant suns, and the quiet promise of discovery. The mysteries of falling stars are not just stories to tell, but whispers from the universe, waiting for those who listen patiently to hear their tale. As the night deepens and the world grows quieter, there's something profoundly calming about gazing upward and watching a meteor streak through the sky. But these fiery travelers are not just fleeting spectacles. They are fragments of cosmic history, messengers from the distant past carrying clues about our solar system's formation and evolution. Each meteor is a tiny piece of a vast, complex puzzle, one that scientists have been piecing together for centuries, slowly revealing the secrets of the universe. One of the first mysteries to unravel was the origin of meteors. Early observers called them shooting stars, imagining them as celestial sparks flung from distant fires. It wasn't until the 19th century that astronomers realized meteors are actually space rocks, bits of debris traveling through the solar system, burning up in Earth's atmosphere. This revelation shifted our understanding profoundly, linking these dazzling flashes to the larger cosmic dance of planets, comets, and asteroids. Meteors vary greatly in size and composition. Most are tiny grains, no larger than a grain of sand, while others can be as big as a basketball or larger. Their composition can range from rocky to metallic, sometimes even containing rare minerals and elements not commonly found on Earth. By studying the tiny fragments that survive passage through the atmosphere and land as meteorites, scientists gain insight into the building blocks of our solar system, the primordial material left over from the Sun's formation billions of years ago. These meteorites are like time capsules. Inside them lie clues about the conditions and processes that shaped planets, moons, and even the earliest stages of life. Some meteorites show signs of having been heated or altered by collisions, revealing a violent past marked by cosmic impacts and reshaping. Others contain organic molecules, the complex carbon-based compounds that are the foundation of life. These discoveries fuel fascinating theories that the ingredients for life on Earth may have come from space, carried by meteorites across the void. Yet, despite our growing knowledge, many questions remain unanswered. One of the most enduring mysteries is how exactly meteors break apart and disintegrate during their fiery fall. As they enter the atmosphere, meteoroids experience extreme forces. Intense friction heats their surface to thousands of degrees Celsius, and pressure builds rapidly as air compresses in front of them. This often causes meteoroids to fragment explosively, creating brilliant fireballs or bolides that can outshine the moon. But predicting which meteoroids will survive this fiery ordeal and reach the ground remains a challenge. Another puzzling aspect is the rare but dramatic sonic booms that some meteors produce. Unlike typical meteors, which are silent or produce faint sounds, these airbursts generate shock waves powerful enough to be heard as thunderous explosions on the ground. The most famous example is the Tunguska event of 1908, when a massive meteor exploded over Siberia, flattening an enormous forest area. Even today, scientists debate the precise nature of this explosion. Was it a comet, an asteroid, or something else entirely? Such events remind us that meteors can have profound impacts on our planet, and understanding their behavior is crucial. One of the most intriguing tools for unraveling these mysteries is the global network of meteor cameras and detectors. These devices, placed strategically around the world, capture images, videos, and other data whenever a meteor passes overhead. By triangulating the meteor's path from multiple vantage points, scientists can calculate its speed, trajectory, and estimated size. This information is invaluable for linking meteors to their parent bodies, the comets or asteroids from which they originated, and for predicting future meteor showers or potential impacts. Meteor showers themselves are a spectacle of cosmic recycling. When Earth crosses the orbit of a comet, it encounters a trail of dust and debris left behind by the comet's journey around the Sun. These particles, usually tiny, burn up in the atmosphere, producing dozens or even hundreds of meteors per hour. The Perseids, for example, are among the most popular meteor showers, peaking each August with dazzling displays that have inspired countless stories and wishes. But behind the beauty lies a dynamic interplay of gravitational forces, orbital mechanics, and solar radiation that shape these streams of cosmic dust. The dynamics of meteor streams are surprisingly complex. Over time, the orbits of dust particles evolve due to gravitational perturbations by planets and the subtle effects of solar radiation pressure. This means that the intensity and timing of meteor showers can change over decades or centuries. Some showers fade away entirely, while new streams can form from recent cometary activity or asteroid collisions. This evolving dance keeps astronomers on their toes, continually updating models and predictions. Adding to the mystery is the occasional appearance of rogue meteors, bright fireballs that do not seem to be associated with any known meteor shower. These sporadic meteors arrive unpredictably from all directions, suggesting a vast and constantly replenished population of debris in near-Earth space. Their random nature makes them difficult to study, but also all the more captivating, as they remind us of the vast, dynamic environment in which Earth exists. The study of meteors is not just academic, it has practical implications for our safety. While most meteors pose no threat, the possibility of a larger impact event has prompted extensive efforts in planetary defense. Detecting, tracking, and potentially deflecting hazardous asteroids or comets is a major focus of space agencies worldwide. Early warning systems, space telescopes, and even proposed missions to nudge asteroids away from Earth orbit reflect humanity's growing awareness of our cosmic environment and the need to protect our home. Yet beyond the science and the safety concerns, meteors continue to inspire awe and wonder. Their brief, brilliant streaks across the sky connect us to the vastness of space and the passage of time. Every meteor is a visitor from distant reaches, carrying stories of cosmic creation and destruction, silently reminding us that we live on a small blue planet in an immense, mysterious universe. So next time you see a shooting star, take a moment to appreciate the journey it has made. From the cold depths of space, blazing through our atmosphere, to a final, fleeting glow. It's a story billions of years in the making, whispered softly across the night sky, inviting us to listen, dream, and wonder. As the fiery streak fades and the night sky returns to its quiet stillness, one question often lingers in the minds of those lucky enough to witness a meteor. What happens next? The answer is a journey from the spectacular to the subtle, from blazing light to silent fragments settling gently on Earth's surface. These fragments, known as meteorites, carry with them the remnants of cosmic history, inviting us to explore not just the universe beyond, but the very origins of our planet and ourselves. Meteorites are the tangible remains of meteoroids that have survived the intense heat and pressure of their fiery descent. Most meteoroids burn up entirely in the atmosphere, leaving behind only a flash of light and a fleeting impression. But the larger or denser ones can endure, cooling rapidly as they plunge through the air and crash onto Earth's surface with varying degrees of impact. When found and studied, meteorites offer a direct link to the building blocks of the solar system, often older than Earth itself. Scientists classify meteorites into several types based on their composition, texture, and origin. The most common are stony meteorites, primarily composed of silicate minerals resembling terrestrial rocks, but often with unique features like tiny spherical inclusions called chondrules. These chondrites are among the oldest known materials in the solar system, dating back over 4.5 billion years. Then there are iron meteorites, composed mostly of metallic iron and nickel, believed to originate from the cores of ancient, differentiated asteroids that once melted and separated into layers. A rarer type, stony iron meteorites, contains a mix of metal and silicate minerals, a curious hybrid reflecting complex formation histories. Each meteorite tells a story, etched in its chemical makeup and physical structure. Some bear the scars of collisions and heating events, indicating violent pasts filled with cosmic crashes and upheavals. Others hold clues to the primordial solar nebula, the swirling cloud of gas and dust from which the sun and planets coalesced. By studying isotopic ratios and trace elements, researchers can reconstruct conditions from billions of years ago, piecing together how planets like Earth formed and evolved. Meteorites have also offered some of the most tantalizing evidence for the origins of life on Earth. Certain carbonaceous chondrites contain complex organic molecules, amino acids, sugars, and even nucleobases, the fundamental building blocks of life's chemistry. These findings support the idea that the raw ingredients for life may have arrived on our planet from space, carried by meteorites and comets, seeding Earth's primordial oceans with the material needed to spark life. This theory, known as panspermia, remains a subject of active research and debate, but it profoundly expands our perspective on life's cosmic connections. The hunt for meteorites on Earth is a meticulous and global endeavor. While meteorites fall everywhere, some regions are more conducive to preserving and finding them. Deserts, with their dry climate and sparse vegetation, provide excellent conditions where meteorites can remain relatively unweathered for thousands of years. Antarctica, with its vast ice fields and stark landscape, is another prime location. Meteorites become embedded in the ice and are concentrated by glacial movements, making them accessible to scientific expeditions. These icy treasures offer pristine samples, untouched by terrestrial processes, enabling unparalleled studies. The retrieval and study of meteorites involve careful techniques. Once a meteorite is located, it's collected with minimal contamination, documented, and transported to laboratories worldwide. Researchers analyze its mineralogy, isotopic composition, and microstructure using advanced methods like electron microscopy, mass spectrometry, and synchrotron radiation. These analyses reveal the meteorite's origin, age, and history, providing invaluable data to astronomers, geologists, and astrobiologists alike. Despite these advances, many meteorites remain enigmas. Some fall to Earth but disappear without a trace, lost to oceans, forests, or urban sprawl. Others arrive as so-called observed falls, witnessed by people and recorded by instruments, but their exact landing sites remain unknown. Even when recovered, some meteorites exhibit unusual properties that challenge existing classification schemes, hinting at processes and materials yet to be fully understood. The stories meteorites tell are not just about the past, they are vital for the future. Understanding the nature and behavior of meteoroids and asteroids is critical for assessing potential impact hazards. Near-Earth objects, some just meters across, cross Earth's orbit regularly, and while most pose no threat, a few have the potential to cause regional or even global damage if they collide with our planet. Monitoring their orbits, sizes, and compositions helps scientists develop strategies for planetary defense, including deflection or disruption missions. International efforts like NASA's Planetary Defense Coordination Office and global telescope networks constantly scan the skies for potentially hazardous asteroids and comets. Early detection and tracking allow for preparation and, ideally, prevention. The knowledge gleaned from meteorites and their parent bodies informs these efforts, providing insights into the physical properties and likely behaviors of these celestial visitors. Yet, beyond the scientific and practical aspects, meteorites capture the imagination and wonder of people worldwide. Cultures throughout history have woven meteorites into their myths and legends, attributing mystical or divine significance to these stones from the sky. Some have been revered as sacred objects, others feared as omens. Today, meteorites continue to inspire artists, writers, and dreamers, symbolizing humanity's connection to the cosmos and the mysteries beyond our world. As you lie beneath the stars, perhaps warmed by the quiet glow of a meteor shower or captivated by a single shooting star, consider the incredible journey that rock has made. From the vastness of space, through fire and fury, to a gentle landing on our planet, each meteorite is a storyteller, a silent witness to the cosmic dance that has shaped our existence. In the stillness of night, as your eyes grow heavy and thoughts drift, the tale of meteors is a reminder of the vastness around us and the delicate threads that bind us to the universe. These streaks of light are not just transient flashes, but echoes of creation, invitations to wonder, to explore, and to sleep peacefully, knowing the sky holds secrets far older and deeper than any one lifetime. When we think about meteors, our minds often fixate on their brief, blazing appearances. Those sudden streaks of light that tear across the night sky and vanish almost as quickly as they came. But behind that fleeting spectacle lies a story of cosmic motion and ancient journeys that span millions, sometimes billions, of years. Each meteor you see is a messenger from the depths of the solar system, an ancient traveler shaped by the gravity of planets, the chaos of collisions, and the silent push of sunlight itself. Meteoroids, the objects that become meteors when they enter Earth's atmosphere, originate primarily from two main sources: the asteroid belt between Mars and Jupiter, and the debris left behind by comets. The asteroid belt is a vast region populated by rocky fragments and minor planets, remnants of the early solar system that never coalesced into a full-fledged planet. These space rocks, ranging in size from tiny grains to massive bodies hundreds of kilometers across, occasionally get nudged by gravitational tugs or collisions, sending fragments hurtling toward the inner solar system. Comets, by contrast, are icy bodies that originate from the distant reaches of the solar system, the Kuiper belt beyond Neptune, or the more distant Oort cloud, a vast shell of icy objects that surround our Sun at great distances. As comets approach the Sun, the heat vaporizes their icy surfaces, creating spectacular tails of gas and dust. This shedding of material leaves trails of debris along their orbits. When Earth crosses these trails, we experience meteor showers, annual celestial events where dozens or even hundreds of meteors can be seen radiating from a particular point in the sky. The journey of a meteoroid from its origin to a fiery entry in our atmosphere is anything but simple. Space is a vast and dynamic environment, filled with forces and influences that shape the orbits and velocities of these objects. The gravitational pull of planets, especially the giant Jupiter, acts as a cosmic gatekeeper, shepherding many objects into new orbits or ejecting them from the solar system entirely. Sometimes a meteoroid's path can be altered by collisions with other debris or by subtle but cumulative effects like the Yarkovsky effect, a phenomenon where sunlight heats the surface of a small object, causing it to emit thermal radiation asymmetrically and gradually change its orbit over time. Because of these complex motions, many meteoroids spend millions of years wandering the solar system before finally encountering Earth. Their sizes can vary dramatically, from tiny grains no larger than a pebble to larger rocks tens of meters wide. The smallest ones produce mere flashes that fade unnoticed, while the largest create spectacular fireballs or even cause significant impacts when they reach the ground. One of the most fascinating aspects of meteors is their breathtaking brightness. When a meteoroid enters Earth's atmosphere at high speeds, typically tens of kilometers per second, it compresses and heats the air in front of it to extreme temperatures. This compression creates a shock wave and excites atoms and molecules, causing the air to glow. The meteoroid itself also heats up rapidly, ablating material as it descends, leaving behind a glowing trail of ionized gas and dust called a meteor train. The color, brightness, and duration of a meteor depend on factors such as its size, composition, speed, and the angle at which it enters the atmosphere. Fireballs, exceptionally bright meteors that can sometimes be seen during the day, are often associated with larger meteoroids and can leave persistent trains visible for minutes. Rarely, the explosion of such objects in the atmosphere can produce sonic booms or even cause damage on the ground, as famously happened with the Tunguska event in 1908 and the Chelyabinsk meteor in 2013. But despite the dazzling display, the ultimate fate of most meteoroids is quiet and gentle. Those that survive atmospheric entry and land on Earth become meteorites, as we've explored before. These remnants offer us a physical connection to the early solar system, a way to study materials that have remained largely unchanged for billions of years. They sometimes provide unexpected surprises, unusual minerals, evidence of space weathering, or even clues about organic molecules that might have seeded life. Our fascination with meteors extends far beyond science. For millennia, people have looked to these falling stars with wonder, fear, and hope. Ancient cultures often saw meteors as messages from the gods, omens of change or disaster, or symbols of transformation. Wishes whispered on shooting stars, stories passed down in folklore, and even artistic representations all reveal the deep imprint meteors have left on human imagination. Today, modern technology has allowed us to deepen our understanding. Networks of cameras and sensors now monitor meteor activity around the globe, tracking their trajectories, speeds, and brightness with remarkable precision. Radar systems detect ionization trails in the atmosphere, and even satellites observe fireballs from space. These tools help scientists study the frequency of meteor events, improve predictions of meteor showers, and identify new meteorites on the ground. The continuous monitoring has also revealed surprising details about meteoroids' behavior. Some meteoroids fragment multiple times as they descend, creating a cascade of smaller meteors and meteorites. Others produce complex light curves, flaring and fading unpredictably. Studying these phenomena sheds light on the physical properties of meteoroids, their strength, and how they break apart. Beyond Earth, meteors offer insight into planetary defense, understanding how to detect and respond to potentially hazardous objects that might one day threaten our planet. Early warning systems and impact mitigation strategies rely heavily on knowledge gained through meteor science. As we prepare for possible future encounters, meteors remind us of both the beauty and the vulnerability of our place in the cosmos. And so, the next time your eyes catch a fleeting streak across the night sky, let yourself drift into the mystery behind that simple light. Consider the ancient rock's incredible voyage through time, space, and atmosphere to briefly touch our world. In that moment, the universe invites you to ponder its vastness, its history, and your own small but meaningful connection to it. The mysteries of falling stars are not just in their path or brightness, but in their silent, enduring stories, waiting patiently in the dark, ready to whisper cosmic secrets to those who listen. Beyond the dazzling streaks and brilliant fireballs lies an even deeper mystery: the origins and compositions of meteoroids themselves. These space travelers are far from uniform. They come in a variety of types and materials, each telling a different tale about the early solar system and the processes that shaped it. Understanding these differences unlocks clues not just about their journey through space, but about the history of our cosmic neighborhood. Meteorites, the surviving fragments of meteoroids that reach Earth, are typically classified into three broad categories: stony, iron, and stony iron. Stony meteorites, the most common type, are primarily composed of silicate minerals, the same building blocks that make up Earth's crust. Within this category, there are two main subgroups: chondrites and achondrites. Chondrites are especially intriguing because they contain tiny spherical grains called chondrules, some of the oldest solid materials in the solar system, dating back over 4.5 billion years. These ancient beads formed as molten droplets in the early solar nebula before accreting into larger bodies, preserving a snapshot of the solar system's infancy. Achondrites, on the other hand, are more processed meteorites that come from differentiated parent bodies, objects that once had molten interiors and separated into layers like Earth. These meteorites often originate from asteroids that experienced volcanic activity or melting, offering insight into planetary formation and geologic processes beyond our own planet. Iron meteorites, composed mostly of metallic iron and nickel, are thought to be fragments of the cores of differentiated asteroids that were shattered by collisions. Their crystalline structures, revealed through careful etching in labs, showcase patterns known as Widmanstätten figures, beautiful interlocking bands that form only under the slow cooling conditions deep inside planetary cores. These meteorites provide a rare glimpse into the heart of ancient, long-destroyed worlds. Stony iron meteorites, a rarer class, are mixtures of silicate minerals and metal. They likely represent boundary zones between the metal core and rocky mantle of parent bodies, a hybrid story of planetary differentiation and destruction. But how do scientists identify and classify meteorites that fall to Earth? Careful analysis using microscopes, spectroscopy, and chemical assays reveals their mineralogy, isotopic composition, and structure. These studies often require collaboration between field collectors, laboratory researchers, and sometimes even space missions. Each meteorite is a tiny time capsule, offering evidence about processes like solar radiation exposure, cosmic ray interactions, and impact histories. Some meteorites carry even more tantalizing clues: organic compounds, amino acids, and prebiotic molecules that hint at the chemical ingredients necessary for life. Carbonaceous chondrites, a rare and primitive type of stony meteorite, contain a rich mixture of these compounds, suggesting that meteoroids might have played a role in delivering life's building blocks to the early Earth. This panspermia hypothesis remains a subject of active research, raising profound questions about the origins of life and our place in the universe. Meteoroids don't always come from the asteroid belt. Some trace their origins to the Moon or Mars, ejected by impacts and later making their way to Earth. These rare meteorites, identified by their unique chemical fingerprints and mineralogy, are invaluable scientific treasures. They allow researchers to study other planetary bodies directly without the cost and complexity of sample return missions. The discovery and study of these meteorites also remind us of the dynamic, interconnected nature of our solar system, a place where worlds collide, exchange material, and influence each other's histories in ways we are only beginning to understand. Even with all our modern tools and telescopes, meteoroids and their meteorites continue to surprise us. Sometimes new types are discovered, or samples defy classification, hinting at parent bodies we have yet to identify. Other times, meteorites show signs of cosmic journeys unlike any others, perhaps having orbited the Sun for eons before being captured by Earth's gravity. This ever-unfolding mystery is part of what makes the study of meteors so captivating. Each meteor shower, each fireball, each recovered meteorite adds a new piece to a puzzle that stretches back to the dawn of the solar system, and perhaps even beyond. As we gaze upward at the next falling star, it's humbling to remember that these brief flashes of light are the final moments of an epic saga, a saga of cosmic creation, destruction, and transformation. They are reminders that we live in a universe alive with motion, history, and subtle messages, waiting for us to discover them. So, as your eyes grow heavy and you feel yourself slipping toward sleep, let the mystery of meteors carry you gently away, into dreams where stars blaze silently, ancient rocks drift through dark space, and the quiet secrets of the cosmos whisper softly just beyond the edge of vision. As we continue our quiet journey into the mysteries of meteors, it's worth turning our gaze not just to the rocks themselves, but to the vast cosmic highways they travel, the orbits that guide these wandering visitors through our solar system and into Earth's path. The paths meteoroids take before they become visible, shooting stars are anything but random. They follow complex gravitational dances choreographed by the sun, planets, and sometimes even the faint pull of distant stars. Most meteoroids originate in the asteroid belt, a broad ring of rocky bodies orbiting the Sun between Mars and Jupiter. This region is a dynamic playground where countless collisions between asteroids produce clouds of debris, fragments ranging from tiny grains to massive boulders, flung in all directions. Some of this debris is nudged into new orbits by the gravitational influence of Jupiter, the solar system's giant, whose immense mass can pull or push these fragments onto paths that intersect with Earth's orbit. These fragments become meteoroids, and when Earth crosses their path, we are treated to meteor showers, spectacular celestial fireworks that happen like clockwork, year after year. But not all meteoroids come from this busy belt of rocks. Some have more exotic origins. Comets, those icy travelers from the outer solar system, also shed dust and small particles as they near the sun. These particles spread along the comet's orbit, creating dusty trails that Earth sometimes passes through, igniting meteor showers that feel different from their asteroid-borne cousins. Cometary meteors often burn brighter, sometimes leaving glowing trails called trains, and occasionally producing fireballs that outshine the moon. This blending of origins, asteroid and comet, gives meteor watchers a varied and fascinating show. Yet the complexity of meteoroid orbits is deeper still. Gravitational interactions with planets, known as perturbations, can alter their courses over time. Sometimes these interactions cause meteoroids to enter chaotic orbits, their trajectories shifting unpredictably as they weave between planets or even get temporarily captured by Earth's gravity before hurtling away again. These transient visitors are called temporarily captured orbiters, or mini-moons, and their fleeting presence adds layers to our understanding of near-Earth space. Space agencies and astronomers track many near-Earth objects, NEOs, to predict potential impacts and understand orbital behaviors. Yet, despite decades of observation, the vastness of space and the small size of meteoroids mean many remain undetected until they enter Earth's atmosphere in a blaze of light. This hidden population of space debris reminds us that our cosmic neighborhood is still largely unexplored and full of surprises. There is also the question of how meteoroids survive their fiery journey through Earth's atmosphere. The process of atmospheric entry is violent and transformative. As a meteoroid speeds into the air at tens of kilometers per second, it encounters increasing friction with air molecules. This friction heats the meteoroid's surface to thousands of degrees Celsius, causing it to glow brightly and lose mass through ablation, the shedding of molten and vaporized material. This glowing trail is the meteor we see streaking across the sky. Smaller meteoroids often burn up completely, never reaching the ground. But larger ones can survive this intense ordeal, falling as meteorites. The size, composition, and angle of entry determine how much of the meteoroid will survive and how it will fragment. Sometimes meteoroids explode mid-air in what is called an airburst, releasing vast amounts of energy that can cause shockwaves felt on the surface, a dramatic reminder of the power contained within these small visitors. Interestingly, the sounds meteors produce as they streak overhead have long fascinated observers. While meteors are often thought to be silent, some large fireballs generate audible sounds through several mechanisms, including sonic booms created by their supersonic speeds and electrophonic sounds caused by the interaction of meteor plasma with Earth's magnetic field. Witness reports of hissing, crackling, or even popping sounds, heard simultaneously with the visual display, add a mysterious sensory layer to meteor observation. Despite advances in technology, many aspects of meteoroid behavior remain enigmatic. Scientists continue to debate the specifics of fragmentation processes, the distribution of meteoroid sizes in space, and the detailed chemistry of meteor trails and their interaction with the atmosphere. Some meteor showers produce unexplained patterns of brightness and frequency that hint at complex dynamics within their parent bodies or surrounding space environments. One of the most tantalizing mysteries involves the tiny micrometeorites and cosmic dust that continuously rain down on Earth, invisible to the naked eye. These minuscule particles, remnants of the early solar system, settle gently on Earth's surface, carrying clues about distant stars and galaxies. They challenge our understanding of space weathering and the subtle exchanges between Earth and its cosmic environment. How much material falls each day? How do these particles influence Earth's atmosphere and climate? Questions like these push the boundaries of current science. The study of meteors also intersects with cultural history and human imagination. Throughout time, falling stars have inspired myths, legends, and scientific curiosity. Different cultures have interpreted meteor events as omens, messages from the heavens, or sacred phenomena. Today, while science offers explanations, the wonder and mystery of meteors continue to captivate people worldwide, connecting us to the cosmos in a deeply personal way. As your eyelids grow heavier and the calm of night envelops you, think of the quiet journeys of meteoroids, their ancient origins, their blazing entrance into our skies, and the secrets they carry. Each shooting star is not just a fleeting flash, but a messenger from space, a silent story whispered across the void, inviting us to listen, to wonder, and to dream. As we drift further into the quiet mysteries of meteors, it's fascinating to explore what happens after these fiery visitors make their dazzling descent through Earth's atmosphere. What remains when the light fades and the night sky settles? These remnants, known as meteorites, carry the whispers of the cosmos down to our very fingertips. Their silent presence on our planet connects us physically and chemically to a vast universe that is otherwise beyond reach. Meteorites come in a variety of forms and compositions, each telling a unique story about their origins and the conditions in space. Most are rocky, but some are metallic, made primarily of iron and nickel, and a rarer few are stony iron blends. These differences reveal the processes that shaped their parent bodies, whether they were fragments of ancient asteroids, remnants of planetary cores, or debris from comet nuclei. When a meteorite lands on Earth, it often bears the scars of its journey, a dark, sometimes smooth outer crust called a fusion crust, formed as the surface melted and then cooled rapidly during atmospheric entry. Underneath lies the heart of the meteorite, a window into the early solar system. Scientists carefully study these samples to understand the conditions that prevailed billions of years ago, before Earth itself fully formed. One of the most intriguing aspects of meteorites is the tiny mineral grains they contain, some of which predate our Sun. These pre-solar grains are stardust, particles forged in the hearts of ancient stars, expelled into space by supernovae or stellar winds, and eventually incorporated into the clouds of gas and dust that birthed our solar system. Finding these grains inside meteorites is like holding a piece of a distant star, a relic from before our cosmic neighborhood existed. The analysis of isotopes within meteorites also provides clues about the age and evolution of the solar system. Some meteorites have been dated to about 4.56 billion years old, making them among the oldest known objects available for direct study. This ancient heritage makes meteorites invaluable for piecing together the timeline of planetary formation, the dynamics of early solar system collisions, and the origins of water and organic molecules on Earth. Beyond their scientific value, meteorites have fascinated humans for millennia. Many cultures regarded them as sacred or mystical objects, often attributing supernatural powers or divine origin to these strange stones fallen from the sky. Today, meteorite hunting is a serious and passionate pursuit, with enthusiasts and scientists scouring deserts, Antarctica's icy plains, and remote landscapes in search of these cosmic gifts. Antarctica, in particular, is a treasure trove for meteorite collectors. The continent's vast ice sheets and slow-moving glaciers concentrate meteorites in certain regions, where dark stones stand out starkly against the white background. The cold and dry conditions preserve meteorites exceptionally well, making Antarctica one of the richest sources for scientific samples. Each find adds a new chapter to our understanding of the solar system and offers clues about the diversity of extraterrestrial material. But meteorites also pose intriguing questions. Some carry organic compounds, amino acids, and other building blocks of life, sparking debate about the role of extraterrestrial materials in the origin of life on Earth. Could these space rocks have seeded our planet with the ingredients necessary for biology? This idea, known as panspermia, remains controversial but highlights the profound connection between Earth and the cosmos. Even the arrival of meteorites is often unpredictable and mysterious. While many are small and harmless, larger meteorite falls have been recorded throughout history, sometimes causing significant impact events. The famous Tunguska event in 1908, for example, flattened thousands of square kilometers of Siberian forest in a massive airburst explosion, thought to have been caused by an object tens of meters in size exploding mid-air. Despite its scale, no impact crater was found, deepening the mystery of its exact nature and trajectory. More recently, in 2013, the Chelyabinsk meteor exploded over Russia, injuring over 1,000 people and shattering windows across a wide area. This event was a stark reminder of the ongoing risk posed by near-Earth objects, many of which remain undetected until they are very close. It also underscored how even relatively small meteoroids can pack enormous energy and cause real-world consequences. Because of these risks, global efforts exist to track and catalog near-Earth objects, searching for potentially hazardous asteroids and comets. Space agencies like NASA and ESA use powerful telescopes and radar to monitor the skies, hoping to predict future impacts and develop strategies to mitigate them. These initiatives combine cutting-edge science, technology, and international cooperation, a testament to humanity's determination to understand and protect our home. At the same time, meteorites inspire creativity and wonder. Artists, poets, and storytellers have long used falling stars and cosmic rocks as symbols of mystery, destiny, and connection. The sight of a shooting star still prompts millions to make a wish, an instinctual human response to a rare and beautiful celestial event. This blend of scientific inquiry and emotional resonance makes meteors a truly special phenomenon, a bridge between the cold vastness of space and the warmth of human imagination. As you settle into the quiet of night, consider the journey of a meteor. Born in the chaos of the asteroid belt or the icy trails of comets, wandering the solar system for millions of years, speeding toward Earth, blazing across the sky in a flash of light, and sometimes, just sometimes, resting in the soil beneath your feet. These silent travelers carry stories older than time itself, connecting us to the very origins of our solar system and the universe beyond. So next time you see a streak of light darting across the night, remember you're witnessing a moment where space and Earth briefly touch. A cosmic whisper, fleeting but profound, reminding us of the vastness above and the mysteries still waiting to be uncovered. Close your eyes now, let the gentle thought of falling stars carry you into peaceful dreams, and know that somewhere beyond the sky, ancient rocks continue their endless voyage through the silent dark. As we continue to unravel the quiet secrets of meteors and meteorites, it's worth pausing to consider how much of our own planet's story is written in these cosmic visitors. Meteorites don't just land and sit quietly on the ground, they become part of Earth's tapestry, influencing the chemistry, geology, and even the biology of our world. These space-borne messengers have impacted the course of Earth's history in profound and sometimes surprising ways. One of the most famous examples is the asteroid impact that is widely believed to have caused the mass extinction event 66 million years ago, wiping out nearly 3/4 of all species on Earth, including the dinosaurs. This massive collision, forming the Chicxulub crater in what is now the Yucatan Peninsula, released unimaginable energy, triggering wildfires, tsunamis, and a global impact winter. It's a sobering reminder that meteors and asteroids are not just beautiful spectacles but powerful agents of change, shaping the very evolution of life on our planet. But the story of meteorites and their impact on Earth isn't only about destruction. These visitors also bring with them a rich chemical payload. Many meteorites contain water in the form of hydrated minerals, and others carry organic compounds, the molecular building blocks of life. Some scientists believe that these contributions may have helped seed the early Earth with essential ingredients for biology, adding a cosmic dimension to the origin story of life itself. The study of meteorites has revealed an astonishing diversity of chemical compounds, some of which are rare or absent on Earth's surface. These include amino acids, nucleobases, and complex hydrocarbons. Their presence suggests that the basic chemistry necessary for life is not unique to our planet, but widespread throughout the cosmos. This idea deepens our sense of connection to the universe and fuels the search for life beyond Earth. In addition, meteorites often carry clues about processes that shaped the early solar system, including the formation of planets, the role of collisions in shaping their surfaces, and the evolution of organic chemistry in space. Each rock is like a frozen snapshot of cosmic history, preserved in the cold void, waiting to be studied with ever more sophisticated tools and techniques. Our ability to unlock these secrets depends on careful analysis back here on Earth. Laboratories equipped with advanced microscopes, mass spectrometers, and other instruments examine meteorites down to the atomic level. These studies require meticulous work and patience, revealing hidden structures, isotopic ratios, and chemical fingerprints that tell stories of stellar explosions, solar winds, and interstellar dust clouds. Meteorite hunters and researchers also face many challenges. The rarity of meteorites, the difficulty of locating fresh falls, and the complexity of distinguishing genuine specimens from terrestrial rocks make this field a blend of science, detective work, and adventure. Sometimes, meteorites are found in unexpected places: deserts, ice fields, mountain slopes, each environment affecting how the rock is preserved and what it can tell us. Despite these challenges, the rewards are immense. Each meteorite is a piece of the puzzle, helping us understand our place in the cosmos and the forces that shaped our world. They invite us to imagine the vast journeys these rocks have taken, crossing unimaginable distances through space before finally arriving on our doorstep. As you lie in bed, consider this: the dust on your windowsill, the soil beneath your feet, and the stones you walk on may hold echoes of distant stars, supernovae explosions, and primordial clouds of gas and dust. We are all in some way connected to the universe's ancient past through these small, silent travelers. So as you close your eyes tonight, let the thought of meteors falling softly through the atmosphere, silent, swift, and ancient, carry you gently into sleep. Imagine yourself floating quietly beneath the starry sky, watching a bright streak blaze across the heavens, a fleeting messenger from the depths of space whispering cosmic secrets in a language of light and dust. Sleep well, knowing that somewhere above and all around us, the universe is in constant motion, sending pieces of its story down to Earth, inviting us to listen, wonder, and dream. As our journey through the silent trails of meteors nears its gentle end, let's take a moment to reflect on the quiet mystery of how these cosmic visitors influence us not just scientifically, but culturally, emotionally, and even spiritually. Throughout human history, meteors have inspired awe, wonder, fear, and hope. They have been seen as omens, messengers, or signs from beyond, fleeting lights that connect the heavens with the earth in a moment of shimmering beauty. Different cultures across the world have woven falling stars into their myths and stories. To the ancient Greeks, meteors were tears shed by the gods, or celestial arrows shot across the night sky. Indigenous peoples often viewed them as spirits traveling between worlds, or messages from ancestors watching over from above. In Japan, the soft, quick flash of a meteor is called a ryusei, or falling star, and making a wish upon it is a cherished tradition, just as it is in many other places. These stories, passed down through generations, reveal something universal: a deep human need to find meaning in the vast, mysterious universe we inhabit. Meteors, with their sudden appearance and vanishing act, remind us of the ephemeral nature of existence and the constant dance between the eternal and the transient. But beyond their cultural symbolism, meteors quietly influence our collective imagination and curiosity. They invite us to look up, to pause in the stillness of night, and to consider the bigger picture, that we are part of a vast cosmic ballet. Each streak of light is a brief but brilliant thread in that grand tapestry. Modern science may have explained many aspects of meteors, their composition, their origin, their impact, yet the mystery lingers. We still grapple with questions about the full extent of their influence on Earth's geology and life. How often do smaller meteorites affect our planet's atmosphere, climate, or even biology in subtle ways we are just beginning to understand? What undiscovered secrets do these stones hold, waiting patiently beneath layers of ice or buried deep in the soil? The exploration continues, aided by telescopes scanning the skies, satellites tracking near-Earth objects, and space missions like OSIRIS-REx and Hayabusa 2 that bring samples from asteroids to Earth. These missions allow us to study the very materials that birth meteors, offering unparalleled insight into the building blocks of the solar system. In the quiet laboratories where scientists examine every grain and molecule, new stories unfold about how planets formed, how organic compounds traveled across the cosmos, and even how life's earliest ingredients might have arrived on our world. These discoveries deepen the mystery while enriching our understanding, weaving science and wonder together in an ongoing tale. And perhaps that is the greatest gift of meteors, their ability to inspire awe while reminding us of the vast unknown still waiting to be discovered. They are silent travelers, messengers of both past and future, connecting Earth to the cosmos in ways both seen and unseen. As you drift toward sleep tonight, let the quiet light of a falling star guide you into dreams filled with cosmic wonder. Imagine yourself riding alongside these tiny travelers, sailing through the silent void between planets, witnessing the birth of stars, the dance of galaxies, and the timeless beauty of the universe. The mysteries of meteors are not just about science or spectacle. They are a doorway to imagination, a bridge between the earthly and the cosmic, a lullaby from the stars themselves. Sleep well, friend, and may your dreams be as bright and fleeting as a shooting star crossing the velvet sky. And now, as we gently close this chapter on the quiet journeys of falling stars, remember that the universe is always whispering to us, through twinkling lights, silent stones, and the soft rustle of cosmic dust drifting through space. Every meteor that streaks across the night sky is a reminder that even in vast darkness, there is movement, there is light, and there is connection. We are part of something far greater than ourselves, a story unfolding across billions of years and countless miles. The next time you find yourself under a starry canopy, take a moment to look up with calm wonder. Watch for that sudden flash, the bright traveler blazing a path across the cosmos. And as it fades into the night, remember that it carries a message, not just of fiery motion, but of ancient history, of silent mysteries, and of a universe still waiting patiently to reveal its secrets. Let this quiet magic lull you into peaceful sleep, your mind drifting like a meteor through the serene expanse of space, light and soft and free. Let the stars watch over you, and the cosmic silence cradle your dreams. Thank you for joining me on this gentle voyage through the mysteries of meteors. If you enjoyed our time together, please feel free to share where you're listening from and what time it is there. I love reading your stories and seeing this sleepy community stretch across the globe. Don't forget to like and subscribe if you want to continue exploring these soothing corners of science with me, one soft-spoken topic at a time. Until next time, this has been the Sleepy Scientist wishing you restful nights, peaceful thoughts, and the quiet comfort of the cosmos wrapped gently around you. Sleep well.